Hi everyone, today we are going to discuss unit 42 and this unit is based on resonance. Sorry, very poor handwriting, but as you can see here we have the resonance. Okay, so in a very first stem it's talking about the identical resonance form. You can see the both are identical. How can I say this is identical? Look at the changes. This is O minus, here we have O minus, here we have C double bond O, C double bond O. So this is equally contributing and they contribute equally to the hybrid structure. Okay. In the second one, it is talking about the drawing of resonance. So you can see this is the CO bond and it breaks down into C plus and O minus. Okay. So oxygen is more electronegative, as you can see in the table. If you're going to compare oxygen and carbon, oxygen is 3.5 and carbon is 2.5. So oxygen grabs the electron like this, clear? So it breaks like plus carbon and oxygen minus. Makes sense? So this is a CO bond breaking. Suppose if I am going to give you this structure and I am saying what should be the resonance drawing of it. So basic connectivity remains same. The change is only like oxygen minus and carbon is plus. So these two are the resonance form and this one contribute more to the hybrid structure. The reason is that you can see resonance form with the separation of unlike charges contribute less than resonance form without such a separation. So it means without charge can contribute more to the hybrid structure. And the third one is you have to compare on the behalf of electronegativity. So we have three resonance form. You can see this one is without charge separation and these two have charges. So more electronegative has negative charge, is more stable. You can see resonance form with a negative charge and the more electronegative atom contribute more than do resonance form with negative charge on the less electronegative atom. Makes sense? So second one, oxygen is more electronegative and that has negative, and here oxygen is more electronegative but that is positive. So negative on more electronegative contribute more. So in 36th question, we have this structure and the question is which of the following is resonance form that will contribute to the hybrid. So you have to figure out which one is a resonance form of this given compound. So we have done this already. Whenever we have C double bond O, we know that it can break like C plus and O minus. So C plus O minus is only in the option A. Clear? How we can eliminate the rest of the option? You know, in resonance structure, the atom and its numbering or number of atom, that should remain same. Look at this one. This carbon have 3 hydrogen, this carbon also have 3 hydrogen. So atom do not change its position. This carbon have 2 methyl group, this one also 2 methyl. Same here, this carbon have 2 hydrogen, this one have 2 hydrogen, this one have 2 hydrogen. So atom do not change its position, only the electron moves. So option C, they have change in the atoms number. You can see this carbon have 3 but this one have 2 hydrogen. So this one is not possible and this one as well. The fourth one is not correct because once you break the CO bond, it should be C plus and O minus. But there is no charge on the carbon and oxygen, and also this carbon has 5 valency, which is wrong. Clear? So option A is the right choice. Now question 37. 4 resonance form for nitrobenzene appear in the option. Which option contribute most to the hybrid? If you look at the stem, this one, the point number 3, you can see without charge is the most stable form. So which one is without charge in all the 4? The very first one. Oh sorry, here we have charges 1 plus 1 minus Here you have 1 plus 2 minus, here we have 1 plus 2 minus, here we have 1 plus and 2 plus and 2 minus. So simply we can say if we have less charge, then that can be more stable. So less charge is only number A. Clear? So B, C, D has more charges than A. Clear? Now question number 38. Pair of resonance form of 3 different substances are given below. And in how many of these substances does the resonance form given on the right contribute most to the hybrid? So we have to figure out in the given pair which one is more stable in the right hand side. So if you look at the very first pair, so without charge is more stable than the charge. So here you have more charges, you can see 1 plus 2 negative, and here we have just 1 negative. So this one is more stable. In the second one, the left one has no charge while the right one have 1 plus and 1 minus 2 charges. So this one is more stable. In the third one, they have equal number of charge, 1 plus and here 1 plus. But if you look at the very last point of the point 3, you can see this point, oxygen is here positive and here oxygen is negative. Clear? So oxygen positive is highly unstable because oxygen is electronegative element. So here oxygen is positive. So this one is more stable. So right side is only one pair. So B is the right choice. Now the next is a resonance hybrid that can be represented as this. Which of the following pair most likely show its contributing resonance form? So hybrid basically defines the property of the resonance structure. So if you look at this one, the very first point, there is no drawing of the hybrid. So here we don't have drawing of hybrid. So let me tell you the hybrid structure. Suppose we have this compound C double bond O. And if you're going to draw the resonance form of this, so we know that this is O minus, this is carbon plus. So if you want to draw the hybrid of this, so number of atom and its connectivity remains same. So look at both the structure. Here oxygen is negative, so we can say delta negative. Carbon is positive, so we can say delta positive. Now C double bond O here, so we can represent with dot line like this. So if this oxygen is negative in the hybrid, it means resonance structure oxygen should be negative. The terminal left oxygen is negative in hybrid, so resonance structure oxygen must be negative. And you can see option number C, oxygen is negative. Either left or right, it doesn't matter, but any one of the oxygen must be negative. While if you look at the D1, this oxygen neutral, this one is neutral. So D is not right. B also, both is neutral. Now this A has oxygen negative. Now look at this nitrogen negative. So right hand side nitrogen is negative, and yes, we have nitrogen negative. But in option A, you can see both right hand side nitrogen is neutral. So A is wrong. Now last question, question 40, which of the following represent the resonance form? So option A, if you look at, this one is OH and this one is just O. So you cannot change the atom's positioning, so A is not right. In STEM, we all knew, we have learned the resonance of CO. So here we have CO bond. So look at this one, N minus double bond C double bond O, and oxygen have a lone pair. Like this. So if you break this, you know that nitrogen oxygen is minus, this one is plus, here we have a double bond, and this nitrogen is negative. So this minus this plus combines, and that makes a bond. So we have a triple bond here. Clear? So this one is a correct resonance form. While option C, in the stem, if you are going to draw the resonance structure, there should be a difference in the electronegativity. You can see CO1, oxygen is more electronegative, carbon is less. And we have the table. but here both are oxygen. In the D1 there is no changes here. You can see this NH2 have a lone pair, oxygen also have a lone pair. Clear? Here also lone pair. If you are going to break or form any bond, there should be a charge here. Makes sense? So this is a lone pair with lone pair case, but there is no charge in the drawing of the resonance form. And this is also the lone pair case, the last one. If you look at this stem, we don't have any case where the lone pair resonance form. Clear? You can see here. There is no lone pair in the neighboring atom. You can see if you look at this CO bond, oxygen has lone pair but carbon is neutral. You can see oxygen have lone pair but carbon is neutral. So lone pair in the neighboring position, there is no resonance condition. Okay, so D is not right. So this is all about the resonance one. Thank you so much.